Well, let's continue. Then I'm standing here on the Linux instance that we were creating along with the bucket that we also created. Now, let's generate the deployment of this architecture. I'm going to come here. Remember that I have to edit a little bit my script, or better said, the installation command of the deploy command. Remember that we are working on installation with an external bucket. Yes, with an external bucket. And here's where, the command, the environment variables to configure before invoking the installation script are those that are raised here, where on the one hand we have the address, where is the bucket created. To access the REDful API that we were talking about, that's why URL. Then we have the bucket access key, that is the access key and the password. That is also what we have registered, exemplifying it in Akamai. The region, we said that it goes null. The bucket name is called course. The bucket that we have created was called course. Then already with these parameters, could raise, run, an instance of Omnily, proceed with the installation of an instance. Before, of course, I have to download the first boot installer. I have it already here, so now I can invoke it. Invoke the installation script, passing it as environment variables, the parameters mentioned, where eth alludes to the network interface, where I have the private IP, the format is, or the environment is cloud, because clearly in a cloud provider now, from there, I want to serve the application. And then I will also take into account this that we just to pass as argument, now that are all the variables necessary to operate with the bucket. Okay, I think it is interesting what is happening. There are some providers that do not give the option to enable or disable. Then what happens is that, remember that the script, what it does, among other things, is to generate the point environment and edit it with set. But here, what happens to us is this, is somehow when discovering that IP address, remember that the first boot installer, what it does, get the IP using this command, this curl, then an improvement for the following versions. But it may be happening. What I'm showing you, what I'm going to do directly is copy the public IP, I have it, then I put it like this, and really, from knowing a bit more, the script also. One is seeing that get stuck here when I was trying to get this up. So what I'm going to do here for now, what I could do is this, right? Come here, and here you should directly put the public IP of the instance. And now go back to run the installer along with the variables. Who does not have this inconvenience? I can obviate this parentheses, but for there it is interesting that happens and that is exposed here in the video of this class for that they know well, where the hand goes sometimes when it throws that error. The error that it threw is for here. There's this, when it throws this address, there we're realizing that it's IPv, and that's where the problem comes from. So, what did I do in the first boot installer installation script? Directly forced not to discover the public IP. But I wrote it directly. Then we will see, and surely in some release, how fixes this so that always works with the iPad IP version 4 and not IP version 6. Well, now it is doing the download of the containers. Let's see what. Just looking a little bit at the first boot installer, there is a part where checks if it is defined or not. The bucket URL. This parameter bucket URL, remember that it comes from the environment variable bucket URL with capital letters. That is the one that we pass, the one that we generate before launching the installation script. And then here, there is an if-else that determines that if it is this variable. If this variable does not exist, then it raises the Docker Compose prot YML stack. Now, if it exists, then among other things, it takes care of making a set of some variables inherent to the object storage theme within the environment point. And then it raises this stack So, now if we go to this stack, we're going to see that, among other things, does not have Minio as component, as container, is not, nor the dependencies that the services ask for, since this remains as an external service. Here we are seeing that, well, it's already doing the checkout, waiting for it to finish. Lift the application. It downloaded all the containers. It lifted the... Notice that among the containers that lifts is not Minio. If Minio is not there, if we are going to find other, and we will be seeing it in the next classes, which has to do with the observability part, monitoring of the application. But well, it is not the case for today. Simply show that in this file in this stack is not going to be minion. Regarding launching or using the application in the cloud. And if it's in a LAN environment and they have a object storage service, it can even be a LAN environment. And that object storage is in the cloud. This is quite interesting. Gives you a lot of robustness to your deployment. Why? Because we are going to have here kept under lock and key and with a very high availability. The information of the recordings, but also a practice that makes all this much more robust is to take backups. We will present in the next class the backup tool to backup Postgres. Then, OmniLeads basically is an application, practically, stateless, where the persistence of the data of business are the relational data, poker, and the call recordings. Object storage, unstructured data, safeguarding, making backup of these two types of data, we can raise the application wherever we want, destroying this machine as many times as we want. Then, simply with a backup, programmed of Postgres to be pushed. The backup of Postgres pushes it directly to the storage footprint. I can even do without this virtual machine Linux. That is to say, if I want to see it as immutable infrastructure, so to speak, and in the next update directly, to raise a machine, new or rebuild this one. I can do it or resizing, whatever, because I don't care how important I am going to persist here and back up both call recordings and relational database information. With those two things, I can already rebuild OmniLead. Well, here already, finished raising the app. Then we are going to access to this, our instance, and we are going to start to see how it operates with it. With the bucket, here I have the bucket. In the bucket, I don't have anything. If I don't have anything, because I just don't, I'm using Omniliads yet. Let's see what. Well, what I'm going to do here is the environment with some test users as we were already doing. So it creates trunk, campaigns, agents, and everything. The trunk as usual. I make a modification because for this occasion, I raised a emulation server to have here in the course. A quick way to validate calls. So I have my trunk zip ready. Let's see this. I'm going to upload an audio. As you well know, in Omniliads, we can work with audio that are uploaded for the IVs. Music on hold that you use the call cues or announcements that are made when you enter a queued call. Let's say asterisks and Omniliads allow to customize, especially the inbound flow of the calls through IVR, through announcements, through music on hold and all that. And, well, they are files that you have to upload to the application. But as you will see, the application itself, Django, and going back to the best, to this that we had seen in the object storage part, where we had presented a graphic where we saw that Omnilit, for example, the media root, which is a Django directory, where, among other things, all these audios that are uploaded are stored, maps it into the container. So now I'm going to do F, and let's see how already Django placed there the audio that I just uploaded. That way. This makes it more stylish. Just why? Because here at the level, the Django that is running the application here does not depend on the file system of the machine. This because this file directly the media root is mapping it in the object storage. Now let's go to the recordings part. Let's see how. The storage of recordings is done here. So, whether it's audio or video, this unstructured data goes into a bucket. Here we have it. If I already have the recording available in the view, but let's do a F also here in the bucket to see that a folder appears with today's date. One file. Now if I do this, let's put here network media, and I'm going to do so. You're going to see that actually the request of the request goes against the IP of the server that's hosting to updelete there. We have, let's say, a path is requested for a file specifically, and this actually makes a 302 a redirect for us to reformulate this and notice what the request goes against now. Goes to the object storage API, to the bucket course, the date, the name of the recording. Look at this. Now let's look at this here. Or let's look at this here. this way. Django tells us that to access this file that lists us inside the recordings view. Actually, we are accessing the API of the object storage. And from there, really, in this case, for example, we could download the recording or listen to it. This is being accessed through this external service, and therefore the cost of storage of this unstructured data is going to come out to price, object storage. And we take the burden off of having to store here, burden of having to store it here on a local disk within the instance of the Linux server.